Okay, this is Unit 4 in Algebra 2 CP. The unit is called Graphing Quadratic Functions, and this is Lesson 1. Lesson 1 is called Properties of Parabolas. All right, so one definition to start. So the unit is called Graphing Quadratic Functions again, and this first definition is quadratic function. Okay. A quadratic function is a function that can be written in the standard form f of x equals ax squared plus bx plus c, where a is not equal to 0. A cannot be 0 because if a is 0, then the x squared term is 0x squared, which is nothing. So it wouldn't be a degree 2. So it wouldn't be a quadratic. So that's why a cannot be 0. So this is the standard form, okay? The ax squared, that's called the quadratic term. Okay, so this is called the quadratic term. The bx, that's called the linear term. And the c, the number that's all by itself without a variable, that is called the constant term. Okay, so a quadratic function has to have ax squared. Okay, so example 1, determine whether each function is linear or quadratic, and identify the quadratic, linear, and constant terms. So for example 1a, let's distribute the -5, and we'll get f of x equals -5 times x will be -5x plus 15 when you do -5 times -3. So since there's no quadratic term, since there's nothing squared, then it's not quadratic, and this is linear. So this is a linear function. And let's identify the quadratic, linear, and constant terms. So write down quadratic term. Let's write down linear term. And let's write down constant term. Now there is no quadratic term, so I'm just going to write down none. The linear term is -5x. Don't forget the negative sign. And the constant term is the 15, and it's positive, so I'm just going to put 15. Okay, example 1b, let's distribute this one, okay? Let's start by distributing the 2x. So 2x squared minus 8x. And then let's distribute the 3. So plus 3x and then minus 12. And let's combine like terms. Let's make that -5x. So f of x equals 2x squared. Always put it in standard form, which is, this is standard form up here, by the way. ax squared plus bx plus c. It says that above. Standard form. So anyway, combining like terms, we get -5x and then the minus 12. So since we have a quadratic term, 2x squared, it means it's a quadratic function. So let's just identify that. And then let's do the same thing that we did for the first one. Let's identify the quadratic term, the linear term, and the constant term. Okay, so the quadratic term first. Quadratic term, linear term, constant term. Quadratic term will be 2x squared linear term will be negative 5x, and the constant term will be negative 12. Okay. So that's the end of that page. Moving on to page 2, key parts of a quadratic function. So first of all, the graph of a quadratic function, you might remember this from the past. It's called a parabola. The graph, the shape is called parabola. So if you look below, this is a parabola. That's the shape name. Okay. The blank is the line that divides a parabola into two parts that are mirror images. That's called the axis of symmetry. So if you look at the diagram below, okay, this line right here cuts the parabola in half into two halves of the mirror images of each other. So that is called the axis of symmetry. The vertex. Next one is vertex. The vertex is the point at which the parabola intersects the axis of symmetry. That right there, that's called the vertex. Right there. The y value of the vertex represents the maximum value or minimum value, depending on whether the graph opens up or down. So in this example right here, this is the vertex. So the y value that corresponds to that, in this case -4, that would be the minimum value because it's the lowest value. Okay, so the y value represents either the minimum value or the maximum value. And these next two definitions of review. A x-intercept is a point where the graph crosses the x-axis, and a y-intercept is a point where the graph crosses the y-axis. Okay, now we have two examples. Some of this involves stuff we did earlier in the year, and I did mention that before. Identify the axis of symmetry, the vertex, the maximum or the minimum, the x-intercepts, the y-intercepts, the domain, that's review from earlier. Same thing with the range, increasing intervals, decreasing intervals, and end behavior. All of that you have to identify. So it's a lot to this problem. Looks like there's 10 things we have to answer. Okay, let's go in order. Let's start with the axis of symmetry. I'll start right here. The axis of symmetry is a line that goes through the center of the graph. So in this example, the axis of symmetry would be the vertical line right here. A vertical line is always x equals a number when you write the equation, and the number is 1. So the axis of symmetry, you're going to write down x equals 1. It's a line. If you just put 1, that would be incorrect. It's x equals 1 because it's a line, and that's how you write the equation of that line. Next up is the vertex. The vertex is that point right there. It's an ordered pair, 1, -4. So again, the way that you write it matters. So 1, -4. The maximum or the minimum next. I'm going in order. Maximum or minimum. This one has a minimum because it has a lowest point, and the lowest point is -4. So I'm going to write down minimum equals -4. Okay. Again, I'm going in order. Let's do the x-intercepts next. There's 2 of them for this example. The graph crosses the x-axis right there and right there. So we have 2 x-intercepts. Make sure you write them the right way. I'm going to say -1, 0, and 3, 0. Now, if you're doing IXLs on this, the IXLs might accept just -1 and 3. I would like you to write them out as ordered pairs on tests and quizzes. So -1, 0 and 3, 0. Okay. Next up, let's do the y-intercept. Okay, we're going in order. So next up will be the y-intercept, where the graph crosses the y-axis, 0, -3. That's how I'd like you to write the answers for tests and quizzes for the x and y-intercepts. Next up, we got domain. So if you remember back to Unit 2, the domain is the x values in this graph. What x values are in this graph? The graph is going to keep going to the left forever, and the graph is going to keep going to the right forever. So the domain will be -infinity all the way up to infinity. You always put parentheses next to the infinities. Okay, range will be the y values in this graph. So the y values in this graph go from -4 up to infinity. So the way you write that is smaller number first, -4 up to infinity, parentheses around the infinities always, and you put a bracket around the -4 like that. Next up, we got the increasing intervals. Remember, we use the x values, and we always use parentheses. So it's increasing. Let me try to do it in color. This is where the graph is increasing in blue. Okay, so the graph is increasing in that blue region. The x values that correspond to that, I'm going to color that in right now. So I colored in the x values in blue, that it's increasing. So you can see it's increasing from 1 all the way up to infinity. So I write that like this, 1 to infinity like that. Next up, we got the decreasing intervals. Okay. The graph is decreasing in this red region. Okay, that's where it's going downhill. That's where it's going downhill in red. The x values that correspond to that, I'm going to color those in right now. Because you always use the x values when you're doing the intervals. That's from Unit 2. Lesson 2. I don't know why I have that memorized. But anyway, these are the x values where it's decreasing. So -infinity all the way up to 1. And last but not least is the end behavior. As x approaches -infinity and as x approaches +infinity. As x approaches -infinity, as x gets smaller and smaller, the graph is going up towards +infinity. And as x approaches +infinity, the graph is going up, so it's approaching +infinity there as well. So both of them are approaching +infinity in each end. Okay, let's do the next one. I'll go a little faster this time because we just did one. This will be the final example. Axis of symmetry first. Okay, so same directions. I'm going to do those same 10 things. Let's start with the axis of symmetry. The axis of symmetry is a line that goes right through the middle of the graph. So in this case, it's x equals 1. Same answer as the first one. That's just a coincidence. Okay. It's the vertical line through the center of the graph. Next up, we got the vertex, which is right there, that point. You can estimate it. It looks like it's about 1 and then 4.5. So I'll put 1, comma 4.5. This one has a maximum because it has a highest point. Example 2 was a minimum. This example is a maximum. So the maximum equals 4.5. The maximum or minimum is always the y value of the vertex. So in this case, 4.5. Next up, we got the x-intercepts. Where the graph crosses the x-axis. So -2, 0 and 4, 0. The y-intercept is where the graph crosses the y-axis. So in this case, it crosses the y-axis right there. So the y-intercept is 0, 4. Domain is the x values in the graph. These x values are going to keep going to the left forever, and the graph is going to keep going to the right forever. So the domain will be -infinity all the way up to infinity. The range is the y values in the graph. So the y values, they keep going down forever, and they go all the way up to about 4.5, and they stop there. So I'm going to say -infinity, comma, 4.5, a bracket next to the 4.5, parenthesis next to -infinity, like that. And now we got 3 more things. We got the increasing interval. These are the hardest ones. Then we got the decreasing interval we have to do still. And then we have the end behavior. So, and these are the hard ones, I feel like, for most people. These are the tricky ones. So where's the graph increasing? Let me color it in blue, the actual graph first. This is where the graph is increasing. This is where it's going uphill. Okay, so that's where it's increasing. So let me color in the x values that correspond to that. So these are the x values that correspond to where the graph is going uphill. So those x values are from -infinity all the way up to 1. So my increasing interval, I'm going to put -infinity up to 1. Again, these always go in parentheses, the intervals. Decreasing intervals means where's the graph going downhill. So let me color that part of the graph in red. That's where it's decreasing. The x values that correspond to that, I'm going to color in red. So that'll be 1 to infinity. Okay. And the end behavior, so as x approaches -infinity, f of x approaches, we'll fill that in a minute. As x approaches positive infinity, f of x approaches, we'll fill that in a minute as well. So in each direction, the graph is going down. So at each end, it's approaching -infinity. Okay, so -infinity and -infinity. And that is the end of that lesson. Again, that lesson was called Properties of Parabolas.